problem you faced? Okay, how many of you have completed the MATLAB portion? None of you.
You see, there you should face a problem. That's why we asked that you should do it.
Yeah. Yeah, unless they should do it, they will not get acquainted with that. Means whatever we have explained, so we have explained, so you have to do it in the MATLAB one by one. Means, and also please don't write one entire MATLAB code. First write one small 2-3 lines, then check the answer whether what was desired. Means then you do it step by step. Okay. So we are not getting any response from the students. Even they are not asking any questions or they are not writing anything in the chat box. So what we can think of it?
So it seems then everything fine with them.
Yeah, it is fine. Then we can start with the next lab. Then submit your record by tomorrow. It was scheduled to. It was scheduled for tomorrow, I think.
8.
Yeah.
The date is that it was 8.
Yeah. It was 8th. 8th. Yeah. 8th October.
And usually we take attendance at 2:05, and I see that just now 2 or 3 more persons entered. So you missed your attendance. Well, it seems they don't have any questions. I just want to highlight a few points, and then we can stop and hand it over to TAs if they have any MATLAB HFSS related issue. Well, first of all, last we discussed about ABCD parameters, and I referred to a table given in DM Pojar's book. So once you have ABCD parameters for this whole band stop filter unit, then you can convert it to S parameters using that formula given in DM Pojar's book. But it seems that you did not try it, otherwise you should report some problem. So in the other lab, what I have seen, sorry, one important point you missed, that whatever given in DM Pojar's book, it is valid only for a two-port network when port 1 and port 2, both of them have the same impedance Z0. So when you are doing for this band stop filter, port 1 50 ohm, port 2 50 ohm, you should not face any problem with that. You just calculate ABCD parameters for these 3 different sections and multiply them to get overall ABCD parameters, and then you use that conversion formula. Now, how to proceed for this single step situation or quarter wave transformer? For single step matching, it is a load problem. It is not a two-port network. So we have just one port, port 1, and now looking into your load, complex load, RL plus JXL through a matching network. So at the design frequency, it should be perfectly matched. That means magnitude of S11 should be 0, or in dB scale minus infinity. Now again, you should not face any problem. How to proceed for this one? You can calculate what is the Z in. You can derive an expression for that looking from port 1. So once you have Z in, then what is your gamma in? That is Z in minus Z naught by Z in plus Z naught. Use that formula, and in MATLAB you plot S11. Okay. Next, coming to quarter wave transformer. For quarter wave transformer, one side port impedance 50 ohm, another side port impedance 100 ohm. Even though it's a single section of transmission line of length theta, let's say theta should be 90° at design frequency. So here that means you can't apply that conversion formula because your port impedances are different. Then how to proceed for this case? If you look at the files I uploaded, let me also show it. So you go to file tab, and there you see that I uploaded one paper, microwave theory and technique. Okay, let me open that window. Yeah, this one. So it was a paper in February 94, published in IEEE Transactions on Microwave Theory and Techniques. Okay, so here general derivation is given. It's not that complicated. Mostly they used circuit theory for the derivation. You don't have to go through each and every line. You have to just use the formula, conversion formula given here. Look at table 1. So here you can see S11, 12, 21, etc. defined in terms of Z, ABCD, and others. So for the ABCD, now you see port 1, port 2, they considered different impedances, Z01 and Z02. Not only that, they also considered the situation when Z01 and Z02 can be complex, port impedance complex. So considering that, look at the formula. S11, it is given A Z02 plus B minus C Z01 complex conjugate into Z02 minus D Z01 star. So you have to use this set of equations for quarter wave transformer. I was expecting question for this part actually. Okay, so that was from us, and now if you have any questions, so please ask.
So for the quarter wave transformer, S11 will be calculated as ZL minus Z0 by ZL plus Z0, or Z in minus Z0 by Z in plus Z0.
Oh, sorry, I was muted. I think you could not hear. Again,
Yes,
let me
sir.
repeat. So for the quarter wave transformer, it is a two-port problem where these two different ports have two different impedances. Port 1 50 ohm, port 2 100 ohm. You can do S11 and S22, you can calculate differently, but you have to do many steps. Instead of that, you use that conversion formula, you will get directly overall S11, S22, S21, S12. It's a two-port problem. But I asked for the one-port problem where you are matching to a complex load. In that case, you can derive expression for gamma in or S11. So basically, you have to find Z in for that one-port problem. And once you have Z in, then you do Z in minus Z naught by Z in plus Z naught. That is your S11.
Yes, sir. So my in that case, my point of reference would be my input port, which is 50 ohms.
Exactly. Exactly.
Okay, sir.
So you might have noticed in HFSS for the lump port, you can represent even complex, you can define complex impedance, real plus imaginary. But for the wave port, it is only real. There is no option of defining imaginary port. So depending on requirement, then accordingly, you choose proper port.
And sir, between the lumped and wave force, like I noticed in the last experiment, like if you're using the wave force, you get a diagram. But if I was irrespective of what I did, I was always getting a beta of zeros. Like, imaginary part of gamma was always, I was trying to plot it and it was getting zeros. So, like, what exactly is the difference between those two?
Those two means wave port and lump port.
Yeah. So, like, why was like this happening? Like, imaginary part of gamma was getting zero. So, like, it, the both are like resistance, right? So, like, they both simulate resistance, right?
What is the relationship with resistance and beta? Beta you are doing for the guiding structure, right?
Yeah,
And
yeah.
one port you are using as the source, another port you are using as the load. And these points we discussed many times that beta directly given by HFSS, it is not always correct. There are some issues. It is valid only for some special scenario. If you have a uniform transmission line supporting TEMOA, so that's why you were suggested to follow length difference method. Okay, you have to follow that
Yeah,
length
nahi.
difference method. Now, difference between, you go through HFSS manual and find out what is the difference. Wave port, it is like a more general scenario, but with some restriction. For example, you have to align it with boundary and other things. So it first calculate the port mode and it checks that is it a TE type mode, TM type mode, or TEM type mode. So it checks first and then do the calculation based on that mode. In fact, some of the times you can force the wave mode to excite the electric field in one direction. There is one indication line. For lump port, it is for TEM case, and you can apply it anywhere in the circuit, even inside the boundary. There are some more specific properties. You go through HFSS manual.
Thank you.
HFSS simulation part will be handing it over to PS, so you can discuss with them. For the theoretical part, MATLAB coding part, or conceptual part, if you face any problem, so please ask us now. check your assignment deadline. And the report should be in proper format. We kept some marks on your representation. We discussed again many times what we are expecting and how we are expecting in your report. Any other question?
None right now, but there might be an issue while we progress with the experiment. At such a moment, do we email you what questions we might be having?
You see, we are not expecting any more question for this part. That's why this class we kept as additional class. Okay, instead we could ask you to submit by yesterday. So it can't go to infinity. You were supposed to complete it by yesterday, and this was an additional class. This is to discuss this type of things. So you did not go through it, that is your problem. From next class onward, we are going to start new topic. If any question come by today or tomorrow, that of course we will take care, but not after that.
Hello, sir.
Yes.
Sir, I actually had a simulation related problem. I was calculating the required length from an online calculator. And whenever the length was differing by a very small amount, like fourth or fifth place of decimal, the S11 minima was varying very much, like
No.
from 2.4 gigahertz to 2.3 gigahertz. So is it possible or?
No. After point, you are doing in millimeter, centimeter, meter. What is your unit?
Some millimeters.
In millimeter, usually after point, we just consider two digits, because we can't fabricate to that accurate value. And as an engineer, you should take care of that. So there is no meaning. If you want to buy, let's say you are going to market and you are asking, okay, give me 1.25780 kilogram potato, so most probably he will laugh at you.
Oh, okay, sir. So I have to keep the dimensions in up to 2 decimal places.
Yes.
That will
Yes.
solve my problem.
That is
Okay, sir.
no, that will not solve your problem. That is more
Means
than enough. Now
okay.
let's say you check what is your length you calculated. I'm giving some numerical value. Let's say it's 5 millimeter.
Okay.
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 So 5 millimeter is giving a dip at 2.4 gigahertz. I'm just taking some arbitrary numerical example. 5 millimeter at 2.4 gigahertz. Now instead of 5 millimeter, if I change it by 0.1
Okay.
millimeter, 5.1, then you can use arithmetic formula.
Okay, sir.
New frequency dip, since it is increased 5.1, new frequency dip, it will be at 2.4. Note it down. 2.4 multiplied by 5 divided by 5.1. So what
Okay.
is the shift? It's very close, right? Even for a change of 0.1 millimeter.
Yes, sir.
It's just a few megahertz. So you most probably you have problem in your simulation setup.
Okay. Sir, I actually consider the three lines. I consider them as separate metal plates. Should
Okay,
I?
that's why that screen sharing other things we'll hand it over to our TS, then you will be doing that with them.
Okay, okay, sir.
Okay, so the theoretical part, conceptual part, you can ask right now.
Okay, sir. Thank you, sir.
We liked your first question. That was conceptual.
Okay, sir.
So those type of question we are expecting more from you. Any other problem like as Shovik was sharing? So Professor Mohan, then should we end this session and hand it over to our TS?
Yes, I think so.
Okay, then thank you all. So we are not creating any new meeting window since it seems that number of questions are very much limited. We are just leaving myself and Professor Mohan leaving from this, and TAs are going to continue. So you can share your screen with them to discuss any specific simulation related problem. Okay, so we expect actually you should share your screen and discuss the problems. Well, thank you all. Bye. And if you face any problem, as I said that till today you are welcome. Tomorrow you are welcome. We will be answering in the chat window. After that, we are going to start a new topic. And when you are coming to new class, you go through manual. We will be asking you a few random question. Based on that, we will give you some marks also. So antenna parameters basically. What are the different parameters? Okay. Thank you. Bye.
Thank you.